Below, we will show and explain a little about certain topics of relevance in the world of physics, and with the purpose of promoting new knowledge never before revealed. The four interactions of the energy. In particle physics, it is called the fundamental force to each of the classes of interactions between subatomic particles: strong, electromagnetic, weak, and gravity. Strong. This force is responsible for holding together the nucleons, protons, and neutrons that coexist in the atomic nucleus, overcoming the electromagnetic repulsion between the protons that possess electric charge of the same sign, positive, and counting the neutrons, which they do not have electric charge. They remain united to each other and also to the protons. Weak. This force is responsible for natural phenomena such as radioactive decay. The most familiar effect is beta decay of neutrons in the atomic nucleus and radioactivity. The word weak derives from the fact that a force field is 10 times smaller than the strong nuclear interaction. The next is electromagnetic. This energy is the amount of energy stored in a region of space that can be attributed to the presence of an electromagnetic field, and which is expressed in the function of the magnetic field and electric field intensities. Finally, the gravity. In the century 17, Isaac Newton came up with answers to this question. It has been proven in many occasions and is now known as the law of universal gravitation. The bodies, by the mere fact of having mass, exert a force of attraction at the distance on other bodies with mass. This interaction between bodies at a distance is called gravitational interaction, and the force of attraction, gravitational force. For continue, in this table we present both the cavities and the particles where these energy interactions essentially take place. For example, the gravitation, weak and electromagnetic, act on the electrons, muons, and neutrons. The strong nuclear force is one of the four fundamental forces that the standard model of particle physics establishes to explain the forces between particles. This force is responsible for holding together the nucleons, protons, and neutrons that coexist in the atomic nucleus, overcoming the electromagnetic repulsion between the protons that have the same positive charge and counting the neutrons, which do not have electric charge, remain attached to each other and also to protons. Allows to join the quarks to form hadrons. Quarks are massive elemental fermions that interact strongly forming nuclear matter, and certain types of particles called hadrons. The electromagnetic interaction occurs between electrically charged particles. Here the particles also have charge, the charge of color. Its action, despite being the strongest, is only appreciated at very short distance. According to the standard model, the mediator particle of this force is the gluon. The theory that describes this interaction is quantum chromodynamics and was proposed by David Politzer, Frank Wilson, and David Cross in the 80s. As a collateral result of the interaction between quarks, there is a manifestation of the strong nuclear force that explains that within the atomic nucleus to protons and neutrons. Due to the positive charge of the protons, for them to be stable in the nucleus, there must be a force stronger than the electromagnetic to retain them. We now know that the real cause of the protons and neutrons not being destabilized is the so-called residual strong interaction. This interaction between nucleus, protons, and neutrons occurs through pairs of quark-antiquark in the form pions. For continue, we are talking about of all of types of energy in the world. We start with the solar energy. It is the energy produced by the sun and is converted to useful energy by humans, either to heat something or produce electricity. Each year, the sun sheds 4,000 times more energy than we consume, so its potential is virtually unlimited. The intensity of the energy available at a particular point in the Earth depends on the day of the year, the time, and the latitude. In addition, the amount of energy that can be collected depends on the orientation of the receiving device. It is currently one of the most developed and used renewable energies in the world. Other type of energy is the aeolic. The wind energy is one of the abundant and renewable energies of the nature. It comes from the conversion of the kinetic energy that the masses of moving air bring to the mechanical energy and then to electric energy. To achieve these conversions, machines called with turbines are used. But actually, the hydraulic energy is most popular because it's based on taking advantage of the water fall from a certain height to produce electrical energy. It's obtained from the use of kinetic energies and potentials of water flow or natural waterfalls. In the process, the potential power during the waterfall becomes kinetic and moves a turbine to take advantage of energy. Nuclear energy. Nuclear energy is one that is related as a result of a nuclear reaction. The physicists who studied that matter posited that the energy of a particle was determined by the speed that it had. However, Albert Einstein argued that the particles had energy regardless of the velocity they carried. This observation was the origin of the nuclear age. It can be obtained by the process of nuclear fission, is the division of heavy atomic nuclei, or by nuclear fusion, union of very light atomic nuclei. In nuclear reactions, a great amount of energy is released because part of the mass of the particles involved in the process is transformed directly into energy. These reactions occur in the nuclei of some chemical elements, radioisotopes, the best now being the fission of uranium-235, with which the nuclear reactors work, and the most common in the nature inside the star, fusion of deuterium-tritium 2H3H. The advantages of the nuclear energy is a clean, safe, and competitive source of energy. It is the only source of energy that can replace a significant part of the fossil fuels, like coal, oil, and gas, that massively pollute the atmosphere and contribute to the greenhouse effect. In a report of April 2011, the production of energy by nuclear reactors around the planet approximately contributes a quarter of energy that is used in some countries, and in others is used more than half. It is concluded that provides 30.8% worldwide.
Okay, to continue, we talk about 6 basic resources of electrical energy. For example, heat, light, pressure, rubbing, magnetism, and chemical action. Then, we can observe the manifestation of energy in the nature. For example, the wind, the movement of the plates in the earth crust, a volcano, solar radiation, the power that occurs the fissionary or nuclear nucleus, the movement of waves or ocean currents, and glacier displacement. Okay, to continue, we talk about the transformation of energy in nature or through technology. The technology has always been used through nature, in this case, the energy we can get from it, in order to use the daily in life of man. For example, the energy: electrical energy, lighting energy, mechanical energy, thermal energy, wind energy, solar energy, nuclear energy, chemical energy, hydraulic energy, photovoltaic energy, geothermal energy, seawater energy, electromagnetic energy, hydroelectric energy, and magnetic energy. All these types of energy over time have been used for different things. It is what technology has been able to create use from the natural, new energies and their use in the life.
Application of technology managed to turn different types of energies. Today, there are several ways to convert energy, whether renewable or non-renewable. The society has been in charge of investigation for a long time the process of obtaining energy. The use of technology has been made into different machinery that extract the various fossil fuels, or also the ones in charge of producing electric energy, to be able to supply the millions of families. Notwithstanding the consequence of this process to generate data looked for other alternatives, they called renewable energies. Non-renewable energy sources are those that are limited in the planet and whose speed of consumption is greater than that of their generation. There are several non-renewable energies such as fossil fuels like coal, oil and natural gas, and the nuclear energy and its process of fusion and fission. The renewable energy are sources in which the available energy exists in unlimited quantities, so that they do not deplete or they used. The sun, wind, waterfalls, and biomass are examples of renewable energy sources. Up to now, the renewable energy has been seen as the best alternative over non-renewable, because where solar and wind energy are the main ones that cover a large part of the energy demand, 60% in 2012 to be exact.